It's Bill again, and today we're going to cover the geometry of the universe. I want to show people kind of what the universe looks like before the Big Bang and then after the Big Bang, and also show how other particles are encoded on host particles, cosmic horizons. So pre-Big Bang universal geometry. So there's going to be 10 to the 122 individual particles that each have 10 to the 122 cosmic horizons. And each one of these cosmic horizons is only 10 to the negative 18 meters, or about that small, like quark small in radius. And now remember, Hawking photons represent erased Planck areas, so each one of those little universes will have 10 to the 122 Hawking photons. Now these little universes are causally out of contact with each other. Their horizons are sort of touched to each other because there's nowhere else in the universe to go. There's no other reference for these other universes to go. So each cosmic horizon is causally isolated from every other cosmic horizon because they're like little tiny black holes at this point, inverted black holes. So the size of the entire universe at 10 to the 122 particles is only about 1 million light years wide. And that's got 10 to the 122 observable universes in there. But at that scale, when you get down to 10 to the negative 18 meters, the Hawking photons condense into neutrino-like spin particles. And this fortifies the horizon, rebuilds the horizon, and makes the cosmic horizon very large again. So you can see here that we have an orange, blue, purple, and yellow universes here, and they're cosmically isolated from each other. But after those Hawking photons condense into like neutrino-like particles, and they're basically grow the horizon as those particles cross the local horizons, then it looks something more like this. So now these horizons have grown, and it's not to scale obviously, but these horizons will grow from something very small to something very large. And here we see that those universes were previously out of causal contact with each other are in causal contact. You can see now that orange is in contact with blue, blue with purple, and purple with gold. This is the same pattern as we had on the previous page. Exact same pattern. All we did was expand the horizons. And this is how when an expanding cosmic horizon, how it encodes another host particle's spin and creates a guest particle out of it. So here we have orange's cosmic horizon is expanding, blue is out of contact, but it's flowing across. And now orange's cosmic horizon is starting to bend around blue here. And remember, this horizon here is relative to the host particle. So when it's expanding out, it comes across this blue particle here, it starts to bend in, and it costs one horizon area to encode this as holographically as blue particles spin on orange's horizon. Now the same thing also happens for blue and orange. Orange will cross blue's horizon in the same way. And this is basically how all particles get encoded in the Big Bang. You have 10 to the 122 particles out here, or something very large. The horizon expands because the Hawking photons grew the horizon, and then the horizon expands wider and wider, comes in and sweeps in more new particles. A new particle does cost a little bit of information here, costs 1 Planck area, but remember that even though this cost 1 Planck area, particles that are close to this horizon are going to be gravitated across, or appear to be gravitated across, and that's going to make this horizon bigger. It's going to add Planck areas on that horizon. So now orange and blue can both interact in each other's observable universes. And we talked earlier about the moment that orange's cosmic horizon encodes blue's spin as a guest particle. Blue's horizon also encodes orange's spin information as an orange guest particle. And now orange can go around in blue space, and blue can go around in orange's space. Because remember, the cosmic horizon follows the particle wherever it goes. So Basically, wherever you're moving in other people's cosmic horizon space that they've created, and then in your own, you can't move in your own, you can't get closer or further away from your own cosmic horizon. And that is it for this little slideshow. I just kind of wanted to show some people kind of what a pre-Big Bang geometry looks like, what it looks like sort of afterwards, how particles get encoded holographically as spin information, how a host becomes a guest. Back up a little bit. This is basically a host particle here. It's still a host, but it's encoded in Orange's universe as a guest right there. And that is it. Have a great day and watch my other videos. Come discover Gravity with Maxime videos, and we'll talk to you later.